Next, I would like to call upon our second keynote speaker, Dr. Suhender from Indonesia. So our second keynote speaker is a professor of fishery resources management, coastal environment and marine science at the Agency for the Assessment and Application of Technology in Jakarta, Indonesia. He graduated as Doctor of Science from the Department of Earth Science, Systems and Technology, Interdisciplinary Graduate School of Engineering Science, Kyushu University, Japan in 2002. He served as the Director of the Center for Development, Education and Training of BPPT from 2014 until 2020. As an Indonesian National Group Leader of Physical Oceanography of Japan Society for the Promotions of Science, JSPS, Asian Core Program. His research activities are focusing on the assessment of coastal environment and fishery resources management using satellite oceanography, field observations, as well as fishery oceanography and hydro-oceanography study. At the moment, he's doing a research of SACHOEMAR concept application for developing sustainable aquaculture model within Indonesia coastal area collaboration with North Pacific Marine Science Organizations pieces. Without wasting time, I would like to call Dr. Suhender.
Thank you, moderator. Can you hear my voice?
Yeah. Very loud and clear, Doctor.
Yeah. Okay. Thank you. It is my honor to have an opportunity to share information about the rainwater of the AI script. Sorry. Can you see my presentation?
Yes, hello? We do, Doctor.
Yeah, okay. Thank you. So it is a great opportunity for me to have the information about rainwater in Indonesia, harvesting and uses. So I would like to thank first to the organizing committee, to Director Professor Anwar from the TATI, and also representative of the Minister of Environment and Water Resources, all speaker and participant of the virtual international seminar of rainwater and engineering and harvesting. So maybe we already know that water is the important resources for our human life to support daily need for the drinking and another activity. So if we look on the Sustainable Development Goals in number 6, clean water and sanitation is one of the Sustainable Development Goal target to be achieved on the this time. So as we know that in Indonesia, maybe similar with the Malaysia as geographically, we have an annual rain is different between geographic. As we look on this map, so there is a lot of high rainwater in more than 4,000 millimeter in some areas, and also in some areas only 1,000 to 4,000 millimeter and less than 1000 millimeter. So climatically, rainwater is depend on the climate situation in according to the geographical situation, like in the western part, uh, middle part, and eastern part is different situation. While in Indonesian part, in western part, is mostly dominated by the what high water what from the rainy season. So maybe similar with the Malaysia, Indonesian tropical climate is mostly compared to maybe the two seasons, rainy and dry season. So the rainwater also is depend on the season and dry season. And we also in the rainy season, of course, there is a lot of rainy come to the rainy season, and but in dry season not so many. And in water cycle, there is a water cycle. Also, maybe we already know that rainwater come from where? There is come from the evaporation from the ocean and lake and something like maybe BPPT knows that how the rain water come and coming in to the earth, and how to how we can use the rainwater for daily life in Indonesia, something that. How we can use here is we already know the impact of uncontrolled rain and use of rainwater. Yes, maybe rainwater for some time it's useful maybe for us, but sometimes also make our travel often cause flooding and also erosion in some area, like in this figure. And also actually rainwater is very useful to generate electricity if we can collect it better by using on the reservoir by using on the but also sometimes everybody enjoy with the plant by using recreation like in this video enjoy with the also of course for the other activity also we can use for fisheries activity in the lake, pond, and something else. Also, it is very useful for the what for the lake, pond, and something else. For the what is it for the paddy fields and also for drinking. Maybe can we change our slide? This just for using paddy fields and also for drinking. Maybe can we change our slide? This just for using paddy fields and also for drinking. Maybe. I'm sorry, trouble in my system. Sorry. I'm sorry. Okay. Okay. Can you look my presentation. Hello? Hello?
Can, Prof. Can.
Oh, okay, I'm sorry. Yeah, okay.
Going fine. Okay, can proceed.
Yes. Okay, it is okay? Yeah.
Okay, everything okay?
Yeah, okay. Okay, so it is the impact of uncontrolled rain water and use of rainwater. Sometime, like in Jakarta, we have a flood in the road and something there. So it is a big trouble for us how to manage the rainwater in Indonesia. Also in some areas also cause the erosion and something there. So in these matters, of course, if we uncontrolled the rain, will be give trouble for our life. Also, like here is flood also cause the economic activity disturb and something there. But if we can use, you can manage the rainwater like by using in the reservoir and something there. So we can use for the electricity and something there. And the others is maybe for we can use for the what it is recreation and something like that, and paddy fields and fisheries, and also for paddies and drinking water. Here is usefulness of benefits of rainwater for human. Could it be cancer or that? Of course, if we if we didn't process of the rainwater better, maybe it will be disturbed of our health. As we know that rainwater is contained of the salts, H2O, nitric and sulfuric acid, and carbon substance. Of course, if we use directly from the source, maybe it is not good for drinking. So we have to process the rainwater is better. Then the benefits of rainwater here for human health, maybe we can see that we have high alkaline pH and cleanses the skin and prevent the cancer or something there. Rainwater is also good for health because we have to collect it from the rain, more than 20 minutes. So the perspective will get for our health if we can use directly. So maybe the source of rainwater, of course, it's depend on the geographical station. For the big city like in Jakarta, which the air may be contained of the pollution on the air, maybe the quality of rainwater will be not so good like in the villages or the area where is the outside of the city, where is the air quality is better. So the water quality also, of course, it's influenced by the quality of air. So if we would like to use the rainwater, of course, we have to process properly. It is we can do by ourselves or by industrial, like the company of the water. Here, the rainwater for everyday life. So we can use the rainwater utilization system or RAS. This system will make it easy for us to manage rain through various stages. The first stage will begin with collecting rain in the water reservoir, after which the water will be flowed through the special filter pipe and stored in the tap. And then the water also can be stored in the tap and used in dry season as a water storage, something. So in the pipe, there are 4 to 6 types of filter, so that the water flowing through the last pipe is safe for the consumption. So to install the system in our home, we need professional builders, of course, because the process and calculation is quite complicated. If we look at this picture, so maybe we can imagine how the harvesting of rainwater in our home. It is we can collect it by this tank, aquarium, and something that we can collect from the roof to the lid, and maybe we can find soil, and also it can be used for the gardening. So another thing, how to treat rainwater is we can also safely the rainwater by for technique rain absorption. As we know, in 2020, several areas in Jabodetabek were greeted with flash flood. So it caused we have to think how to reduce the water, the rainwater from the during the rainy season. So to avoid the same disaster, we must understand biotechniques that care treatment for soil and cement using techniques. So to fertilize the soil, also it is to fertilize the soil. In addition to fertilizing the soil, these techniques can also protect home from the flood. So we can develop biopore in our garden to reduce the floods surrounding by our house. Biopore in holes are we can dig 70 to 90 centimeters deep with a whole diameter of 10 to 20 centimeters. As we look in this picture, so we can dig 70 to 90 centimeters like this. So we can also put organic waste and something there, and also the water from the biopore can be also support for the the tree or gardening and something like that in our garden. So after extracting organic waste, and this organic waste acts as food for living things. Living things, it is a garden or tree or the others. So if we want to make a biopore hole, so make sure the oil, of course, we have to know the stability of the soil. So the biopore can be developed and built perfectly. Here, the thing is rainwater storage tank. So of course, we can how to harvest the rainwater. It is the easiest process, I think, to keep the water resulting from continuous rain. So we only need a water reservoir that is placed on the side of front of the house, and the result of this shelter can be used for light daily purposes, such as watering plants and washing cars, something like that. Also for consumption use, we must filter rain the tank using water. So if we look the schematic review of the harvesting rainwater here, so the rainwater come through from the roof here, and we can also we have two filtration with small thing of filter here, and we can collect it on the tub, something there. Also we can use the pump for the watering of the garden and something there, of course, also we can use for the drinking water for this filter. Here is water rain quality in Indonesia. If we compare with the Australia, the pH value of the rainwater quality in Indonesia is a little bit normal. Yeah, 7 to 7. It is from the Depok, West Java. Semarang is Central Java, and Pandangan is West Java. If we compare to the with the Australian area in Merify and Finchley Wells, it is a little in Indonesia it is normal. Australia is little bit. So the acidity of the rainwater, maybe it is cause also corrosive of the material or something there. So it should be processed properly for thinking and here is rainwater treatment methods that we develop in our institution and also all of in another institution in Indonesia. That how to reduce total suspended solid like sediment. This we can use by filtration of silica filter media, slow sand filter, coagulation, flocculation process, apparatus, filtration and filtration with ultrafiltration membrane. So the total spending time come from the rainwater can be just maybe is good for drinking. And how to reduce micropollutant? This we can use filtration with activated carbon and carbon oxide. We can reduce with aeration, alkaline substances and similar. And for pH adjustment, we can treatment with alkaline substances. And for iron, reducing iron, I think it is the important element of the for the protection of the our infrastructure or equipment especially in our home, because if the rain of the water is contain high iron, it will be corrosive and also will be destroy installation piping system, especially by using iron. So we have to process by pre-chlorination, pH control aeration, with ferrous barrier action, and with manganese catalyzed oxidation and osmosis. And to reduce manganese is by oxidation and flocculation and sand filter, pre-chlorination oxidation, and also we can contact filtration of filter by contain MnO2 and double filtration, and to process with slow state. And of course, we have also biological parameter like plankton, something like that. So we have to use the chemical copper sulfate, chlorine, chlorine, and cyanide for microfiber. Of course, every help also maybe get a smell. Sometimes we have get smell. If the water contain high iron, also will give us this bad smell with iron. So we have to remove the smell either by aeration, remove chlorination, and also process with active carbon, chlorination, and ozone treatment. Of course, how to reduce detergent and phenol. So maybe in some water containers of the detergent, we can use carbon active treatment, biological treatment, oxidation, and lime. And also color. Color, of course, if we get color brownish or something greenish and something green, it is not good for us to see the water with colors. So we have to process by coagulation and population something. There's also there is chlorine by using processing with active alumina. Turbidity also we can reduce by processing coagulation preparation, hardness by softening and process, nitrate demineralization process, ammonia exchange, and something like that. So of course there is at least that 20 first one component should be hit from the rainwater. If we would like to get good good quality of water, it is of course depend on the type of the utilization of the rainwater. For housing, maybe and our health, human health, maybe it is more should be more should be more perfectly to process the rainwater. But for another users, like for fisheries and something that maybe it is not necessary to get like in house our needs. So it is a systematic review of the rainwater filtration system and filtration harvesting rainwater from the house. It is we can collect the rainwater here, and we send to the we flow to the what it is and retain in water international with how 10 to 12 meter cubic. Also, we can use this one is water to be input to here. It is just to share, to share the the capacity of this tank to this one. So from this system, so we can save rainwater and also for storing during the dry or less than water during the rainy season. So the benefits and technical specification of rainwater, I think. So the benefits here of the how if we can develop the storage and bioforest something like that to save the rainwater. So it is also benefits. It is we save the use of groundwater. Also we can use the holes by 10 cubic meters of water when it rains. It is also beneficial. We can reduce runoff and rainfall load during heavy rain. Also, of course, we can increase the amount of water and enters the ground, maintaining groundwater level, reducing the concentration of groundwater pollution, and of course, we can improve shallow groundwater quality, reducing the rate of vegetation, sedimentation, and also reducing the dimension of drainage, and the others. And it is a technical specification of the the installation of the filtering system and storage system of the rainwater. Here is a simple water treatment technology by using neutralizing by pipeline limestone, aeration, air pumping, coagulation, population, and filtering. On also from this flowchart, see that raw water It should be neutralized of the pH and aeration, and by using air also with a coagulation and filtration, so it is ready for clean water. And used for daily. It is the simple one, rainwater storage using aeration pump, spray, and something that is clean water. It is the simple one in the maybe in the villages area. And this rainwater treatment technology by using slow sand filter here. The source of the water, it can come from the river, embung, or lake. And also we have to tape develop the building here, and also we can flow the river to this hub, using sand filter here and smoothing, and also we can maintain content of the gravel layer and levels of sand, and we can produce the clean water here. So it is the diagram of clean water treatment process with slow up sand water. It is the simple, or maybe the simple equipment and construction of the how to treat the rainwater with the slow sand filter. This this picture capacity with 100 meter cubic per day. It is the rainwater treatment, another technology. It is a diagram of the process removing iron and manganese in water by coordinated infiltration, something like that. So rainwater storage here, we can pump here to the reactor tank and sand filter and that out to produce the clean water or something. Then it is the preview of the equipment. Gel with manganese filter and active carbon filter for removal of the iron, Fa and manganese by potassium permanganate of chlorine. Here, rainwater storage, also we can use the pump and dosing something and then flow to the reactor tank and xylate manganese and active carbon and process water solution. And it is another more complete, this rainwater. It is almost similar, how to the treatment of rainwater with manganese zeolite filters and active carbon filter with positive ion exchange. And here is we show you about the rainwater treatment with membrane technology. So according to Lane 207, filtering level of the rainwater treatment is by using microfiltration, ultrafiltration, nanofiltration, and reverse osmosis, RO. So this is a particle size of distribution that can be put into the level of precipitation and something there. So by reverse osmosis, here is the result, and by nanofiltration, here is the start, and ultrafiltration, here is start, and microfiltration, here is start. And here is how to harvest rainwater by maybe it is more simple, but it is a little bit complicated, but maybe we can make more simple the system. Principally, you have to how to use the filter system to use rain water before for the daily activity in our home, something like that. And here is rainwater treatment technology. to produce the water ready to drink. Maybe. And this is we can develop for small scale home industry or industrial scale. So this schematic is specific for the unit and for ready to drink water. This processing capacity is 10,000 to 15,000 liters per day, and chemical dosing pump 4.7 liters per minute, precision, and raw water pump something. There is a static mixer, multimedia filter, salt tank, patient exchange, cartridge, ultrafiltration, and the others. Yeah. Here is the important thing is there is UP. UP sterilization, yeah, and of course we need ethics, stainless steel, and something like that. So it is a little bit, there is a more level of the how to produce the water ready to drink from the rainwater or something. Here is rainwater technology, the equipment here. It is a rainwater storage tank. We can dug and build the rainwater tank here in front of our house or our small scale industry, and it is raw water pumps, static mixer, and it is the result of processes water with crude and gallon. Maybe similar in Malaysia also something like that. And this one is heating water treatment unit with reverse osmosis process with capacity 100 to 200 liters per day. And then here is how to treat the rainwater into ready to drink water, and using here is using biofiltration, ultrafiltration, and reverse osmosis. That's the important element I think for biofiltration system, ultrafiltration system, and reverse osmosis, osmosis, and UV ultrafiltration here, and biofiltration. And if we already through to this system, so we have a good quality water ready for drinking. So it is ultrafiltration capacity with diagram on 135 liter per minute. We have reverse osmosis capacity 12 liter per minute. So the advantage of the ultrafiltration process is, of course, we can process without using coagulant or propellant, but only using a small amount of chlorine to prevent biofouling and get in a chlorine residual content to prevent recontamination. So this quality water is very good and stable by using ultrafiltration here. And also the shape is more compact and require a smaller, and of course very flexible. If there is additional capacity, if we would like to increase the capacity, something like that. So all filters are out of bacteria, suspended solid, colors, colloid particles, silicate, and registered between corneal and manganese. So using pure chemical filtration techniques, the result of much more good. So raw water content can fluctuate over time, but filtered water will always be the same. By using ultrafiltration, we don't have, then we don't need civil formation because it's already in the skin mounted base, so installation is quick and easy. It is also low electricity consumption and maintenance costs. And of course, it is good economic interest also.
Sorry, Dr. Suhender. One of our listener would like to ask you a question. So this is a question from Muhammad Saifullah. He asks, how much is the cost for setting up ultrafiltration process?
Yeah. Of course, here is about 100 million, 150 million rupee, maybe. How much in Malaysia? Maybe we can divide 3,000, something like that. Yeah.
Oh, I see. Okay. Thank you so much, Doctor.
Yeah. So it is, maybe you can see from this picture, there is raw water. Here is raw water. It is outlet biofiltration. It is the result of the outlet ultrafiltration, and it is air of product, and it is bottled water. So we can compare the results of the water ready harvested from rainwater, ready to drink, and something like that. Yeah. We can compare with the commercial bottled water here, like aqua product and something there. So if we can install we can install the equipment or instrument in our house for harvesting rainwater, and of course maybe not only water comes from the rain, but also we can use from the Sometimes we have groundwater, maybe. Groundwater also, like in my home, is high concentration of iron. So we have to reduce the iron, and of course it is not good for health, also for cooking and something like that. I think that's all. From my presentation. Thank you very much. If any question, we can ask you. Thank you.
Thank you so much, Dr. Suhender, for insight on rainwater harvesting and its diversity uses in Indonesia. We have learned a lot from the various methods employed in Indonesia. So I'll be very honored to be a part of this, to learn about all these methods that you have employed in Indonesia. Ladies and gentlemen, our seminar will have a 10-minute break, and we'll be resuming back
before
after
that. Can I ask
after that.
Dr. Suhendran a question?
After the breaks, we will have an opening speech from Yang Berhormat Datuk Sri Tuan Ibrahim Tuan Man, Minister of Environment and Water. Hold on, can you give me one?
Yeah. I have a question for Dr. Suhendran. Can you hear me?
Yes, please proceed.
Yeah. Can you make, is there any maintenance issue on your proposed system? Maintenance.
Yeah, of course, we have to maintenance, especially for the filtering system, and also mechanical system and something like that. So we have regularly treat the filter system to provide good quality water. Like in our home, there is the name of backwash, something like that. But maybe we can maintenance only on the filter system, like sand filter and UV filter and something that maybe. Because we can see that all filtering system we can it is of course regularly, weekly, or something like we have to check and control the filtering system to provide good water quality as we would like to get what level of water quality, something like that.
Yeah, but you see, during maintenance, after you clean up, it's very dirty. After
Yes.
how long can you get clean water again? Do you do testing? Because you have to remember, in the remote area, nobody can check. There's no QC. So you can clean, you run out the water. So all those things are big issue. I mean, it looks very simple, but these are the big issue.
Yeah. I think it is maybe the simple one, like in our home, we have a filtering system. So we can, there is the utilization called filtering system. There is a backwash and plus out and something that maybe something like that. We have to check like ultrafiltration. Of course, we can check if it is should be removed and changed. So we have to remove. Every system we have a manual system how to maintenance the equipment and all component of the system like filtration and pump, something that should be clean, something that controlling system is the most important thing for our guidance how to how and when we have to clean the system.
Doctor, I got no problem. Doctor, I got no problem with the urban. You talk about the remote and rural area. You mentioned the system. These are the problem one. Urban, no problem. Okay. Farm, filter, backflow, no problem. Those are the area I am concerned. It's just my comment. It's okay. No need to go detail. Thank you.
Any more questions from Mr. Gary Lee?
No more. Thank you.
All right. Thank you, Mr. So, ladies and gentlemen, we're going to have our break, our 10-minute breaks. Once we come back, we will be what we call it, viewing you with a video from Yang Berhormat Datuk Seri Tuan Ibrahim Tuan Man, Minister of Environment and Water. So I will resume the breaks. So let's come back within 10 minutes. Thank you, everyone.